In the previous video, we have learnt about the zeroth law of thermodynamics. Correct? Before we move further, let's talk about couple of parameters which are quite important. Under that, the first one is internal energy. Now, internal energy, it is the sum of energies in a particular system, which is based on the kinetic energy of the molecules or the molecular configuration. Configuration in the sense how they are, the orientation, how they are set up, all these things. All right. Now, this is what we mean by the internal energy of the system. Now, it is represented by U, capital letter U. All right. Now, whenever we talk about this internal energy, two types are there. That is the internal potential energy and internal kinetic energy. Internal potential is UP, kinetic is UK. So, the net, or you can say the total internal energy, U is equal to UP plus UK. Now, remember the definition of internal? It is due to the kinetic energy of the molecules or the molecular configuration, right? That configuration is basically the potential energy and the movement is the kinetic energy. All right. So, this is what we mean by the internal energy of the system. Now, generally, we consider two types of things. Okay. The first one is an ideal gas and second one is a real gas. An ideal gas is a hypothetical type of gas. In the sense it obeys every law and it's all assumption. Okay, it's an ideal gas. It doesn't exist. A real gas is one which actually exists, and then we try to figure out, okay, how close it is to being an ideal gas. Now, for an ideal gas, UP, that is the potential energy, will be 0. Okay, the reason is the molecular configuration or even the force of attraction between the molecules within the gas will be 0. Okay, they don't interact at all. That's the assumption. That's why it's an ideal gas. So the potential energy or internal potential energy will be 0. And whatever the internal energy we have, it is only due to the kinetic energy of the molecules. As the molecules move in the air, whatever the kinetic energy they have, that is equal to the total internal energy of the system. Now, see, there are certain characteristics of internal energy, or you can say points or notes or observation, whatever you can call it. Now, here, the first one is that internal energy is a macroscopic state variable. Okay, in the sense that pressure, volume, mass, everything can change the internal energy. Look at this particular figure. So, as we have a particular pressure, particular mass, volume and everything, it has a definite internal energy. So, first characteristic is that internal energy is the macroscopic state variable. Second point is internal energy of the system. Here, it depends on the initial and final state. In the sense, you can say that it is path dependent. Okay, it depends on the path, whereas it is not going to depend on how the state is achieved. In the sense, let's say you have water. Okay, the internal energy of the water right now, and let's say you start to boil the water, that path is there, right? In boiling the water, it is dependent on the path. Whereas how we got the water, did we melt the ice and did we get the water, or we actually got water? That internal energy has nothing to do with it. What matters for internal energy is the present situation, as then what the system is in right now and how the path is changing. Alright, the third characteristic is, suppose say you have a balloon. Okay, assume you have a balloon and then the balloon is filled with gas. The molecules inside the balloon has some kinetic energy. Basically, it has internal energy. Suppose say I move the balloon. Okay, let's say you play, right, the balloon game. Suppose say you move the balloon. The internal energy of the system has nothing to do with the external kinetic energy of the entire system. In the sense, you hit the balloon, you move the balloon, the internal energy of the whatever, the gas in the balloon, it is not going to change. Like in this particular case, the figure what you're seeing. Internal energy depends on the molecules and not on the entire system where it is moving or not. This is the third characteristic. Okay. Now you understood what are the characteristics of internal energy, correct? Now, let's try to understand, can we actually increase the internal energy? If we have to increase or decrease, what do we have to do? Okay, for this, look at this particular figure. In this, see, there are two things what you have to understand. See, the first one is, you have that piston, correct? You have that beaker kind of thing. We generally call it as a piston. This piston, from the bottom part, from below, we are giving the heat. As we start giving heat, what's going to happen? The body start to rise up, as in the gas will start to heat up, correct? As it starts to heat up, the temperature goes from hotter body to colder body. We all know that. In the sense, what's going to happen here? The gas is going to expand. As the gas expands, what's happening here? The internal energy increases. See, we provide heat. Since we provided heat to the body, a work is being done, correct? Since work is being done, the internal energy is increasing, correct? Next, what if we take, see the top part, the piston is connected to a weight, right? Now, suppose in this case, what's going to happen? Assume that the gas is doing the work, in the sense, gas is pushing that particular piston, right? As the gas pushes the piston, work is done by the gas, and because of that, internal energy decreases. That means heat is being lost, work is being done. Okay. Now, here, two important words I just mentioned, heat and work done. See, heat and work done are not state variables. In the sense, both heat and work done, these two are more like the transition. So when I say that heat is provided, it's a transition energy. Okay, heat is provided to the system. Heat is being lost by the system. It's a transition energy. Same way, work also. Okay, so work is being done by the system. Work is done on the system. It's a transition energy. But internal energy is a state variable of the system. Alright. So when we discuss about internal energy, remember what is it and how all we can change the internal energy and what are the characteristics of the internal energy. So this video is all about the internal energy. Then we'll see in the next video, we are going to discuss about the first law of thermodynamics.